Hello, Mr. Skeen. Sue here. I got a question for you, and I think I'm going to catch you out. If it takes 6 men 4 days to do a job, how long will it take 12 men?
Yeah, thanks for that, Sue. Let me just write down what you said. So you said 6 men, and it takes them 4 days, and you want to know how long it will take 12 men to do some work, to do a job. Okay, right. So there's a classic wrong answer here. So it's not 8. Yeah, lots of people say 8. Because if you've got more people doing the work, well, then it's going to take less time, isn't it? A way I quite often think about this is I think, well, how many working days are there? So 6 times 4 is 24. So now if I've got 12 men, so 24 days shared between 12 men is actually 2 days. Now this is an example of inverse proportion, right? You need to be really careful about this. And this is a question that they do try and trick you in exams. I've got a little bit here, just a little bit sort of terminology here, which is obviously at the top of your PDF file. Okay, so let's have a look at a few proper examples. But look out for that. Don't get confused. You've got to kind of think about the context of questions. All right. In exams, they quite often ask this question, or something very similar to that. So let's have a look at this one here again. So again, we got a table. Now this time we're going to say y is inversely proportional to x. So what does that mean? So it still means we still write this bit down here. Inverse proportion means it's like that. So it means if we put a little equal symbol in there, something times this. So you write it like that. And then the rest of the question is essentially is basically the same as what we've been doing already. So look at the link just there. Remember, there's the key, this one. And then what we're going to do is we say, so if x is 10, so just fill it in. So y is 20, k 10. How do I get rid of the 10? It's a divide, so multiply both sides by 10. So we get k is equal to 200. Rewrite this thing. Y equals, now we know that k is 200. Write it there. And now we should be able to fill the rest in quite easily. 200 divided by 1. 200, right? Didn't need my calculator for that one. 200 divided by 5. Okay, so 200 divide 5. There we go. 40. All right. Oh, this is a bit weird because this is it's the other way around, isn't it? Right. Okay. So I'm a little bit unsure. I don't know what I'm going to do with the numbers. So let's write it down. Okay. So let's fill it in. So we know 100 equals 200 over x. So how do I rearrange those things just there? And the easiest thing to do is to say, well, I don't want that x to be a denominator. So if I multiply both sides here by x, so I get 100x equals 200 and divide by the 100. 200. Now, so that's got to equal 2. 200 divided by 100 is 2. Now, you may well have just been able to see that from here. You might have just been able to say 200 divided by 2 is 100. That's fine, of course it is. The reason I've shown you this part is because obviously these numbers might be a bit more awkward. So you might not be able to see it straight away. So it's important to think about this here, right? Don't just think, oh yeah, I know what to do, that's fine. Because if the numbers are not nice, you won't necessarily be able to think like that. Okay, so let's have a look at the other examples that I've given you today. Okay, so let's have a look at this. So y is inversely proportional to, so again, so we just write what it means. What does it mean? We write it like that. Okay, that that means inverse. And now write it with a K in there, right? What it means. You could write it, I suppose. Like we could write this. I don't like this, but okay, that's exactly the same thing. All right, it's just a bit messy. I don't like it. So what do we know? We've got a pairing. What's this pairing going to allow me to do? The pairing will allow me to work out what the K bit is. That's what I need to know. I need to know the constant of proportionality. So what do? Fill in the numbers. We've got 15 equals K over 4. Multiply both sides by 4, and I think you'll find that K is equal to 60. Rewrite this. Y is equal to 60 over X. Right, we don't need that K, right? We just worked it out. So Y, keep writing K. Write 60. Right, it's not going to change. And then find Y when X equals 10. So Y equals 60 over 10. So Y must equal 6 would be our answer. Okay, 60 divided by 10. Ugh, yuck. Right, then it says sketch the graph of the relationship. Right, okay, so let's just by sketch. Look, it didn't even have to. I don't even need to be getting my ruler out. There we go. Right, now when we sketch it, say to yourself this. When this is the x-axis. That's the y-axis, right? So when x is quite small, what would the value of y be? Okay, so by small, imagine that x is 1. It'd be 60. It'd be like right up here somewhere, wouldn't it? Okay. What about when x is 0? 60 divided by... there isn't an answer. What about when x is like 0.1? Huge, up there. What about when x is really big? Like right over here. Like imagine like a really big number. And that's going to be, let's say like 100. So 60 divided by 100. Well, that's like a really small number. It's going to be less than 1. So what will actually happen here, when you get an inverse proportion, you will see this many times. Okay, and you quite often be asked to go and sketch something like this, and it will look a bit like that. These bits here. These are called asymptotes because it will keep going up, but it won't quite get there. Again, going this way, keep going, but it won't quite get to 0. So going down that way. And the other thing we should also get the negative as well. So we get it. It could be like that over there. Okay. Obviously, we do a little bit more work on that. But it's important to think about this here and in sort of practice how to go and sketch some graphs. Right. Leave that with you. Obviously, you've got a few questions. Oh, nearly forgot about this one. Here you go. Check this one in as well. Inversely proportional. Right. So different letters. Right. So inversely proportional. I thought that was the last one. Right. So when t. Right. Okay. So it's the same thing. Look. We're just going to get the connection there. So t equals. So these are the sort of things that you can just practice them, and you can become really good at doing these. There's no excuse really to getting this kind of question wrong in an exam. Yes, the exam questions do tend to kind of sort of change the context a little bit. So if I've got 30 and 5, so 30 equals k over 5, multiply those two things together, and so k equals 150. I actually prefer the inverse proportion ones. Normally because you end up multiplying stuff rather than dividing them. They appear to be harder, but they're quite often easier to do. So now if we piece all this together, what do we got? We've got t equals 150 over n. Right, work out the value of t when n is equal to 10. So here we go. So part B, t equals 150 divided by 10, which is equal to 15. And then the last bit there, work out the... it's done it the other way round. Okay, right, so just rewrite it. So 25, 150 over n. And remember, the best way of doing this is to multiply by the n, divide by the 25. So you end up writing this down. So n equals 150 over 25. You can kind of think about just swapping these two bits around. Probably best not to view it like that, because people misremember little tricks like that, so be a little bit careful. So 150 divided by 12, what am I doing getting a calculator there? I can do that quite easily, man. Alright, there you go, n is 6. Alright, so have a go at doing a few questions, and then next lesson again we'll move things on a little bit further.